Welcome back, guys. Today's tutorial is on how to write numbers in scientific notation, how to place them into scientific notation, and to understand what those powers of 10 mean. So in chemistry and science, a lot of times the data that we are given or the problems that we are given will have numbers that are written in scientific notation. So we just want to look at what that is and how to simply place them into scientific notation, and then if you need to expand it back out, how to do that. So we're going to look at this real quick. There are a few rules that I gave you in class. The first thing to think about is you must have one number that falls between 1 and 9 in front of your decimal. So it does not matter which number it is, but you can only have one. So for example, you cannot have 23, and I'll show you what I mean. You cannot have 23.9 times 10 to the 4th power, because now you have two numbers in front of the decimal, so that does not work. But if you were to put this correctly into scientific notation, you would have something that looks like this: 2.39 times 10 to the 5th power. We'll talk about how to get to that in just a minute. Okay, so one number between 1 and 9 can be placed in front of that decimal. You have to use the power of 10 to an exponent. So let's say in a minute you're going to see how this works. Let's say that you have 8.339, and you'll see in a minute we're going to be moving that decimal to get that one number in front. Well, this one already has one number in front of the decimal, so most students think, well, if I'm doing a scientific notation quiz, I can leave it like that. Wrong. You have to have a power of 10 that is shown. In this case, we would do a 0 as our exponent, because we must have this formation if we are saying we are in scientific notation. So in a minute, we'll look at some examples that show that. The third thing is, I always tell my students, depending on which way you have to move that decimal, your exponent needs a sign, whether it's a positive or a negative exponent. And the way that you know is it's similar to opposite of a number line. If I have to move my decimal to the left to put it into scientific notation, I'm going to have a positive exponent. If I'm moving my decimal to the right, then my exponent will be negative. So let's take a second and look at some examples. In this number, you have 1,711.98 centimeters. We want to write this in scientific notation. So the first thing we do is we have to move our decimal to show only one number in front of that decimal. So we're going to count how many places. That's 1, 2, 3 places. So we're moving our decimal 3 places to the left, so that now it looks like this: 1.71198. And then we're going to have our power of 10, because that was the second rule, and we just need to know what is our exponent going to be. So we moved 3 places, and we move to the left, which means that exponent is going to be a positive 3. That is what that number would be represented in scientific notation. Now, most of the time, for my sake, on my quiz, I might say, hey, you can round to the second decimal place, and then you can leave off the rest of that. You can make it 1.71 times 10 to the 3rd power. So scientific notation, basically it's used because we're trying to represent either extremely large or extremely small numbers in an easier format. So sometimes I understand when you look at these, you think, well, then why am I writing all of this, right? Because now I've just done more work, including all this mumbo jumbo. But the idea here is that if you did have a number that was extremely large, we're talking space science stuff here, like how far is Jupiter from the Earth, right? You're going to have lots and lots of meters there. We could represent that using scientific notation. Okay, so our next example here, we have 578,639 milligrams. Again, we want one number in front of the decimal. 1, 2, 3, 4, 5. So we went 5 places to the left. Moving that decimal to the left means our exponent will be positive, so we're going to rewrite this number as 5.786,390, or let's just say we round it to 2 decimal places, 5.79. And then we have an exponent of 5, and it's positive because our decimal moved left. Okay, so I'm going to clear out this ink, and we'll move on to the next one. Number 3. So this one, you'll see when you start out with this one, is a small number. It's already a decimal. we need to move that decimal so that it ends up with one number. So we're going to go 1, 2, 3 places and stop behind the 8. So now we have 8.73, our power of 10. Now look, 3 places, but this time to the right. That means our exponent is now negative. So we have -3. So the most common mistake I'll see students do here is they will take and they tend to, if they mess this up, they will tend to, let me grab a different color, they will tend to stop in front of the 8 for whatever reason. And then they give me an answer on a quiz that looks like 0.8 times 10 to the -2. Remember that that is not proper scientific notation. That decimal must be behind the 8. Okay, so we're going to go ahead and clear this ink off. And that would be how that one's written. Again, here's a similar problem. We are starting again with a decimal, small number, 1, 2, 3, 4, 5 times, so that it ends up behind the 4. Because we went 5 places to the right, our exponent will be negative this time. So I heard another teacher say this, don't claim to make this up myself, but she said that her students kind of understood or remembered better when they thought about this is a small number that is less than 1. And so once they put it in scientific notation, their exponent was negative. And for whatever reason, the negative sign made them think small number. When it's a positive exponent, you think big number. And so like if you come back to number 2, that's a pretty big number before you put it into scientific notation. So this positive exponent means big number, right? It's positive. So back to number 4, you moved 5 places to the right. Your exponent is going to be a -5. And so that is what we have. So now let's look at some other scenarios where it gets a little different or a little more involved. Here we have something that resembles scientific notation. So a lot of times people see that part, the times 10 to the 3rd, and they think, well, it's already in scientific notation, but it is not, because you'll see that here you do not have one number in front of the decimal. So how you approach a problem like this is you take that decimal and you move it and you say, well, normally this would be +2 exponent. Like I'm going to pretend that's not even there right there. Okay, so we're going to pretend that's not there. If I were to have just 487.50 and I had to move the decimal 2 to the left, then that would be a +2 exponent. So what you do once you figure that part out is you're going to come back over here to the exponent that's present. That's a +3. So we say, well, what is +3 and +2 equal if we combine them? And that's going to be +5. So you want to combine those two things together. So our answer would look like this. We would have a times 10 to the 5th power. Now our next one is kind of similar here. We have this number, we have a power of 10 already that we need to think about. We're going to move our decimal 1, 2, 3 places backwards. 3 to the right normally means I'm going to have a -3 exponent. So if I combine -3 with a +5, that's like saying 5 minus 3, correct? So then what we're left with is 10 to the 2nd power. 5 minus 3 gives us 2. Our new number is written as 6.845 times 10 to the 2nd power. So again, whatever your normal exponent would have been, combine it with the one that is already shown, and just pay attention to the signs. I will say this, I'll kind of make another one up real quick. 0.0024 times 10 to the -4. Okay, let's say we need to write that in scientific notation. If we move our decimal, it's going 1, 2, 3 to the right. Okay, that means this would have been a -3 normally. If I come in here and I combine -3 and -4, pay attention to your signs like you do in math. -3 and -4 combine to give you -7. So then you would have 2.4 times 10 to the -7 on that example in particular. It's supposed to be a multiply sign. Okay, so that is how you do that if it appears that it's already in scientific notation. However, we recognize those don't have one number in front. So here's the last little example I have for how to place numbers into scientific notation, and this is 9.334. So what we recognize first is that the decimal does not have to move at all because we only have one number in front, so that's the good thing. However, this is not written with a power of 10. If you do not have to move the decimal at all, and you need to express this number in scientific notation, you still must use a power of 10. So if I'm not moving my decimal, I'm going to make that exponent a 0, which is actually quite easy to remember. You're not moving it anywhere, so that's a 0. Now, one thing I like to just point out, let's tie back in the things we learned in math. Anything to the 0 power is equal to 1. So when 9.334 times 1 is itself, so this has stayed consistent with what that number is. A lot of students want to tell me that they need to put a 1 there. They just feel like they have to have a number there and it can't be a 0, and that so I can put a 1. No, that would be wrong. If you put a 1, now you are multiplying 9.334 by 10, which makes it 93.34. It's not the original number. So you can have a 0. That would be the proper format if you did not have to move your decimal at all. Okay, so I do hope that that helps you. This was just very basic as far as putting numbers into scientific notation.
Hey everybody, thanks for watching today's tutorial. Be sure that you subscribe to my channel right here, and if you missed our dimensional analysis tutorial, make sure you click here and catch up. See you next time.